In today's lecture, let's explore different algorithms for adding and subtracting. The first method is from left to right. Now normally when you add 679 plus 237, you're going to add from right to left. But in this method, we're going to go from left to right. So we'll start with 6 plus 2. The 6 plus 2 actually represents 600 plus 200, so that actually gives us 800. Then we'll do 7 plus 3, which represents 70 plus 30, which gives us 100. 9 plus 7 is 16, and then we can add these values up to get our answer. 0 plus 0 plus 6 is 6. 0 plus 0 plus 1 is 1. 8 plus 1 gives us 9. And so we do get the same solution as adding from right to left. Now the advantage of this method is it allows students to understand what these place values represent. 6 plus 2 does not represent 6 plus 2. It represents 600 plus 200. So this technique is useful for those students that are just getting started with math. For part B, we'll do the same process. Please pause the video and attempt to do this problem with the left to right algorithm also. Hopefully you have tried the problem on your own. Let's do it together. 1000 plus 2000 gives me 3000. 400 plus 300 gives me 700. 50 plus 80 gives me 130. 7 plus 9 gives us 16. We can add the columns together. The first column is a 6. Second column is a 4. 7 plus 1 is 8. And we bring down the 3. So our solution is 3,846. You could always check your work with a calculator, but make sure you use the left to right algorithm when the directions ask for it. Part C, now we're working with base 5. Let's use the left to right algorithm the same way. We'll stack it. And now let's add from left to right. 4 plus 1 gives us 5. But remember, this is base 5. 5 does not exist in base 5. The only numbers are 0, 1, 2, 3, and 4. So we'll have to divide 5 by 5, and I get 1, remainder 0. So this means 4 plus 1 is actually 1, 0 in base 5. So it's just 1, 0 in base 5. Now we'll do 1 plus 4. Well, 1 plus 4 is again 1, 0. So I'm going to put a 1 and a 0 here. 2 plus 4, that's 6, but 6 does not exist base 5. Let's divide it by 5. I get 1, remainder 1. So this means I have a 1 here and a 1 here. Now we can add. The first column becomes a 1. The second column becomes a 1. The third one is a 1, and the fourth column is a 1. This is our solution. 1, 1, 1, 1, base 5. So again, be careful. The only symbols that are acceptable for base 5 is 0, 1, 2, 3, and 4. So make sure you convert this to base 5 before you add the terms. For part D, I have 5, 4, 3, 4 base 6. And let's add that with 1, 2, 3, 2 base 6. Now we're looking at base 6. 0, 1, 2, 3, 4, 5 are the only acceptable numbers that are in base 6. So let's add from left to right. 5 plus 1, 6. That doesn't exist base 6, so let's divide that by 6. I get 1, remainder 0. So I'm going to put a 0 here and a 1 here. Now you could add additional zeros like we did here for part C, or you could leave it blank, but just be aware there's zeros here. Okay, so I'm just going to continue what we did in part C. I'll add the zeros so we don't have any confusion. Now we'll do 4 plus 2, that's 6 again, so we'll put a 0 and a 1. And then we'll fill in the additional zeros. 3 plus 3, that's again 6, so I'm going to put a 0, put a 1, fill in the additional 0. 4 plus 2 again is 6, but that's just 1 0. And now we can add, this is a 0, this is a 1, 1, 1, 1, and our solution is base 6, so make sure you write base 6 down here so we know it's base 6. And that's our answer for part D. In part B, let's use the lattice algorithm to do the following calculations. For part A, I'm going to stack it, 679 plus 237, and we're going to use the lattice algorithm. So construct a rectangle, just like this. We have 3 digits, so I need 3 different rectangles. And when we do these rectangles, you need to draw diagonals from each of the corners here, just like so. And now we're going to add using the lattice method. 9 plus 7 is 16. So for the first box, this 1 is the tens place, and the 6 is the ones place. So 9 plus 7 represents 16, but we're not going to carry the 1. We're going to leave it like this. 1 for the tens and the 6 for the ones. 7 plus 3 is 10, so we'll put the 1 here for the tens, and the ones place we have 0. 6 plus 2, that gives me 8. So I have the 8 for the ones place, and for the tens place we have nothing. We'll put 0. Now here is how we do the lattice algorithm. We add the diagonals up. So we bring down the 6 here. Then 1 plus 0 is going to give me a 1. Then 1 plus 8 is going to give me a 9. And of course this one gives us a 0, so we don't need to mention it. So our solution is 916, just like we had in part A. Let's try it again for part B. I have 1, 4, 5, 7, 2, 3, 8, 9. We'll draw ourselves that rectangle, and we have 4 rectangles inside that rectangle because there's 4 digits, and then we'll draw our diagonals. So now let's add 7 plus 9, that's 16. So let's put a 1 up here and a 16 down here. This represents 1 10 and 6 ones. 5 plus 8 gives us 13. So we'll put the 3 down here and the 1 up here. 4 plus 3 is 7. That's a 0. and that's a 7. We have 7 ones and no 10s. 1 plus 2, that's 3. No 10s. So we have 0 and a 3 down here. Again, for the lattice algorithm, we're going to add our diagonals. For the first one, we always bring down that right number here, so we'll bring down the 6. Then we'll add the 1 plus 3, that gives me 4. 1 plus 7, that gives me 8. 0 plus 3, that gives me 3. And this here is 0, so we'll leave it out. So our solution, 3,846 using the lattice method. For part C, we're base 5 now, so we have to be extra careful. We'll stack it just like before, and let's make our rectangle and our diagonals. Now remember, we're base 5, so we have 0, 1, 2, 3, 4 are the only acceptable symbols. 2 plus 4 is 6. But 6 does not exist, base 5, so we'll divide it by 5. I get 1, remainder 1. So 6 actually represents 1, 1 in base 5. 1 plus 4 is 5, but 5 does not exist, so we'll divide that by 5. That's 1, remainder 0. So we have a 1 here and a 0 here. 4 plus 1 again is 5, but I know that's going to be 1, remainder 0, so that's 1, 0. Let's add our diagonals. We bring down the first number, that's a 1. This plus this gives us 1. This diagonal gives us 1. We bring down that 1. So our solution is 1, 1, 1, 1, base 5, just like we had in example C. Let's do it again for part D. You're welcome to pause the video and try this problem on your own. Again, we'll draw a rectangle divided by 4 rectangles and then our diagonals. This is base 6. The only symbols are 0, 1, 2, 3, 4, 5. So let's add 4 plus 2. That's 6, but 6 does not exist, base 6. So we'll divide that by 6. That's 1, remainder 0. So we'll put a 1 here and a 0 for the ones. 3 plus 3 again is 6, but I know that's 1, 0. 4 plus 2, that is 6, so that's 1, 0 again. 5 plus 1 is 6, that's another 1, 0. Let's add our diagonals. Bring down the rightmost digit, that's 0. This is a 1. This is a 1. This is a 1. And that's a 1. So our solution for part D is 1, 1, 1, 1, 0, base 6. And that's the exact same thing we got for part D in question A. In example C, let's use the scratch algorithm. Let's try part A using the scratch method. We have 679, 237, 122, 361. Now for the scratch method, we're going to put a scratch every time this number is 10 or more. This scratch represents our tens in this case. Since we're talking about base 10, each scratch represents a 10. Now let's use the scratch method. Each scratch represents a 10. because we're talking about base 10. So let's add 9 plus 7, that's 16. So let's put a scratch and put a little 6 on the right side. This represents 16. 6 plus 2 is 8. 8 plus 1 is 9. We don't need another scratch because it's less than 10. So we'll bring down the 9. Since we have one scratch, we'll have to carry a 1 over. 1 plus 7 is 8. 8 plus 3 is 11. We'll put a scratch and then we'll put a 1. The scratch represents our 10 and this 1 represents the 1s. 1 plus 2 is 3. 3 plus 6 is 9. We'll put a 9 down here. And since we have one scratch, we'll carry over a 1. 1 plus 6 is 7. 7 plus 2 is 9. 9 plus 1 is 10. We'll put a scratch and a 0. Remember, this scratch represents a 10 with 0 ones. Then we'll add 0 plus 3. That gives us 3. Since we had one scratch, we'll carry that over. And we have a 1. So our solution is 1,399. Let's try the scratch method again for part B. I'll stack it up just like we did before. Please pause the video and try these questions on your own, making sure you understand how to get the answer. So let's use the scratch method. 7 plus 9 is 16. Let's cross out the 9 and put 6. This dash represents a 10. 6 plus 1 is 7. We had one scratch, so we'll carry just a 1 over. 1 plus 5 is 6. 6 plus 8 is 14. We'll put a scratch and then a little 1. Then a 4. 4 plus 1 is 5. 5 plus 5 is a 10. We'll put a scratch and then a 0. Now we have 0 here for the ones place, so we'll put a 0. And since we had two scratches, we'll carry a 2 over. 2 plus 4 is 6. 6 plus 3 is 9. 9 plus 2 is 11. We'll put a scratch and then write the ones place. 1 plus 4 is 5. And now we can carry our scratch over. We had just 1, so we'll carry a 1. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 1 is 5. And 5 plus 1 is 6. We don't have any scratches. So this is our solution for part B, 6,507. Again, these scratches are going to be what we have to carry over. So the advantage of this method is we don't have to add large numbers together. Each scratch keeps that placeholder for us. It represents a 10. Part C, we're looking at base 5. So let's write down the numbers. We'll stack it up just like before. Recall for base 5, the numbers are 0, 1, 2, 3, 4, and that's it. We don't have any other numbers for base 5. So as soon as we get to 5 or more, we need to put a scratch because we have to carry over something. So 2 plus 4, that's 6. That's over 5, so we need a scratch. 6 divided by 5 equals 1, remainder 1. So we'll need a 1 for the ones place. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 3 is 7. We'll need a scratch because that's over 5. 7 divided by 5 equals 1, remainder 2. So we'll have a 2 here, which means we bring down a 2. Since we had 2 scratches, we'll carry over a 2. But this 2 represents 2 5s. Now we'll add again. 2 plus 2, that's 4. 4 plus 4 is 8. We'll need a scratch. 8 divided by 5 is 1, remainder 3. So we'll need a 3 down here for the ones. 3 plus 4, that's 7. We'll need another scratch. 7, I know, is 1 remainder 2, so we'll need a 2 here. 2 plus 3 is 5. We'll need another scratch. 5 divided by 5 is 1 remainder 0. So we'll need a 0 here for the ones place. 2 plus 2, 0 plus 2 gives us 2. And now we have to carry over 3 scratches. So that's 3. So our solution is 3, 2, 2, base 5. So as soon as you get to 5 or more, you're going to have to convert that to base 5, and don't forget to carry over for the number of scratches. For part D, let's add 2, 1, 2, 0 base 3 with 1, 2, 1, 2 base 3, 2, 1, 1, 2 base 3, and 1, 1, 1, 0 base 3. Again, we'll use the scratch method. Recall the only acceptable numbers for base 3 is 0, 1, 2, and that is it. For base 3, we only have 3 acceptable symbols. So anything that is 3 or more, don't forget to put a scratch. That's what you need to carry over. Now let's try this question out. We have to add 2 plus 2, which is 4. Since that's 3 or more, we'll need a scratch. 4 divided by 3 equals 1, remainder 1. So we have a 1 for the ones place. Now 1 plus 0 is 1. Since we have 1 scratch, I have to remember to carry that 1 over. 1 plus 2 is 3. We need a scratch. 3 divided by 3 equals 1, remainder 0. And we'll put a 0 here for the ones place. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. We'll need another scratch. And 3, I know, has a remainder of 0, so we'll put a 0 here. Since we have 2 scratches, we'll have to carry a 2 over. And here we just need to remember to bring down the 0. Two plus 1 is 3. 3 plus 2 is 5, but 5 does not exist, base 3. So we'll divide that by 3. I get 1, remainder 2. So we'll put a 2 here. 2 plus 1 is 3. We'll put another scratch. 3, I know, would have a remainder of 0. 0 plus 1 is 1. Now, since we had 2 scratches, we have to remember to carry a 2. 2 plus 2 is 4. We'll put a scratch. I know 4 divided by 3 is 1, remainder 1. So let's put a 1 here. 1 plus 1 is 2. 2 plus 2 is 4. We'll put another scratch. And we know the remainder is 1. 1 plus 1 is 2. Now, since we had 2 scratches, do we have to carry a 2 over? And here is our solution. 2, 2, 1, 0, base 3. So please check your work with mine. Make sure you did it correctly. Don't forget, if you go 3 or more, you'll have to put a scratch and figure out what your remainder is. Let's look at a subtraction algorithm now. The first one we're going to look at is known as the equals addition algorithm. For part A, let's use the equals addition algorithm. To do this method, you'll look at these numbers and try to make them nice hundreds numbers or thousand numbers so it's easy to subtract. Notice that this number is pretty darn close to 200, and 200 is a much prettier number than 176. So let's add 24 to this number so it looks better. It'll look like 200. And since I added 24 here, I'll add 24 on the other side as well, so that I know the subtraction will give me the same answer. 176 plus 24 is 200. 374 plus 24 is 398. Now, 374 minus 176 is a lot more difficult than 398 minus 200. This I can do without a calculator. This is just 198. So the idea is to make one of these numbers in the hundreds, the tens, or the thousands so it's easy to calculate. Let's try it again for part B. For part B, this number would be a lot easier to do, or this subtraction would be a lot easier to do if this was close to what number? If this was close to 50, it would be a lot easier to do. So let's add 3 to make it 50, and I'll do that also for the 129. 129 plus 3 is 132, and 47 plus 3 is 50. Now 129 minus 47 is a lot harder than 132 minus 50. This is doable. I can get my answer pretty quick. I know 2 minus nothing is 0, and 13 minus 5 is just 8. So this gives me 80. Our solution is 80. Now this number is 2,456. It would be a lot easier to do if this was close to 3,000. Now I'm going to add 544 here, so this becomes 3,000. And of course we'll do 544 for the other number as well. This is 7,051, and this is 3,000. So I converted my problem to 7,051 minus 3,000, which is a whole lot easier than 6,507 minus 2,456. Now let's do the subtraction. This is just 4,051. For part D, I want to make this a nice pretty number. Let's add a 1 to it. And as a consequence, we'll add the 1 to the left side as well. This becomes 400, a pretty number. This becomes 58,550. Now this is a lot easier to subtract. I know this is going to be 58,150. So for the equals addition, try to get some nice numbers on the right side, and then you could do the subtraction easily without a calculator.